All right, so this is problem 2.2.83, and they are asking us, I don't think you guys can read that there. I'm going to read it to you. So if a rocket is launched upward from the top of a building, 380 feet high with an initial velocity of 32 feet per second, the height h above ground after t seconds is given by, and then they give us a formula where h is in feet and t is in seconds. They want us to find the maximum height that the rocket reaches, the time it takes to reach this height, and the time it takes to hit the ground. Okay, so let's write this out. So we have h equaling negative 16t squared plus 32t plus 384. Trying to see what my camera is doing here. Okay. All right, and they're telling us, they go ahead and define that h is in feet and that t is in seconds. Okay, and the first question that they ask us, and I'll just call it part A here, it is, what is the maximum height? Okay, all right, so if you just look at this, this is a concave down parabola, so it's going to have this kind of a shape to it. And if you think of what would happen, you know, when you're launching a rocket, it's going to go up and then it's going to come down, and it's going to have a peak place, point right here. And that peak is going to be the vertex. That's going to be the highest point that it's going to reach. So if we want to answer the question of the maximum height, and height would be in feet, then we need to find the h coordinate of this vertex right here. Okay, so the first thing that we want to do is find the x coordinate of it, which is essentially t here. The variables are t and h in terms of x and y, or yeah. So anyways, t is going to be equal to a negative b over 2a. That's our x coordinate of the vertex formula. And remember that b is the coefficient here of t, a is the coefficient of the t squared, so we have negative 32 over 2 times negative 16. And that is negative 32 over negative 32, which ends up being a positive 1. Okay, so what this means right here is that at t equals 1 second, we're actually going to be at our maximum height. Okay, and then if we want to find the actual maximum height, then we need to plug, and if we were to call this h of t, a function of t, if we plug that 1 in there, so everywhere there's a t, I'm going to plug in 1. So I have negative 16 times 1 squared plus 32 times 1 plus 384. Okay, so this is negative 16 plus 32 plus 384. And, you know, if you just simplify that there, you're going to get 400, and this is feet. Okay. All right, so that answers part A. In part B, they actually ask how many seconds will it take for the rocket to reach its maximum height, and that's going to be the 1 second that we found in the process of finding our answer for part A. So this is really the answer for part B there. And then in part C, they want to know how many seconds will it take the rocket to hit the ground. Okay. So the question is, how many seconds will it take the rocket to hit the ground? Okay, so first thing is we're looking for seconds, and that's a value of t. And what it means to hit the ground in terms of our formula, and here's our formula again, is hitting the ground is a height of 0. Okay, so what we really want to do is we want to set this equation here, or this expression, equal to 0, and then solve that. And that will actually tell us when the rocket has hit the ground. Okay, so I notice that there's a common 16 here, so I'm going to divide everything by a negative 16 to get rid of that. So we have t squared minus 2t, and I think that's minus 24, equal to 0. And you can factor this or plug it into the quadratic formula. I'm going to go ahead and factor it. So we have t and t and 6 and 4 minus and plus. Okay, and if I set each of these pieces equal to 0, and we get t is equal to -4 and t is equal to 6. The -4 doesn't make any sense, but t equals 6 seconds. That would be how long it takes before the rocket hits, or that's how long it takes for the rocket to hit the ground. Okay, so that's it in this problem.